Webb's Pinhole mask is letting astronomers resolve details on Io and young stars that ordinary imaging cannot reach. This is Fascinating Frontiers, episode 152. The technique places a mask with several small pinholes in the light path to enable aperture masking interferometry. Teams used it to observe the massive binary Wolf-Rayet 137, the young star PDS-70, and Jupiter's moon Io. The method combines light from separate parts of the telescope mirror to achieve higher resolution than standard imaging. It reveals fine structures such as volcanic features on Io and dust distributions around forming planets. Follow-up observations are planned to track changes in these systems over multiple orbits. This mode on the James Webb Space Telescope adds a new tool for studying protoplanetary disks, directly feeding into ongoing questions about how we characterize exoplanet environments. Webb's aperture masking observations of Io captured surface details at scales previously limited to flyby spacecraft. The mask turns the telescope into an interferometer by sampling light through discrete pinholes, then recombining the beams to reconstruct finer structure. This approach bypassed the glare of Jupiter while resolving volcanic hotspots and plume deposits. The same mode also mapped dust gaps around PDS-70, showing where planets are clearing material. Next, teams will apply the technique to additional targets during upcoming visibility windows. Picture a 6.5 meter mirror reduced, for a few minutes, to a handful of coin-sized openings spaced meters apart. The light that passes through those openings travels separate paths yet still interferes at the detector as though the entire mirror had been used at once. Riding alongside one photon, you would see it take one pinhole route while its twin takes another, the two waves arriving with a tiny delay that encodes the exact angular separation of the source. That delay is measured in fractions of a wavelength, letting the instrument resolve details 10 times finer than the telescope's normal diffraction limit. On Io, the technique isolated individual volcanic vents separated by only tens of kilometers. On PDS-70, it traced gaps in the protoplanetary disk narrower than the orbit of Jupiter. Yet the same mask also discards most of the starlight, so exposure times stretch and faint targets remain out of reach. The open question is whether future masks with hundreds of pinholes, paired with advanced wavefront sensing, can push the resolution even closer to the theoretical maximum set by the mirror diameter itself. Now the same Earth observation approach is being applied closer to home. Sentinel-2 imaged the burned area and smoke plume from Athens wildfires on 2 August. Sentinel-3 recorded the wider smoke extent across parts of Greece. The paired views show both localized damage and regional atmospheric transport. Data will help refine fire spread models used by emergency services. Shifting focus to ancient conditions on another world, re-examined readings from the Spirit rover point to more widespread water on Mars than earlier single measurements suggested. Paulo de Souza re-examined Mossbauer spectrometer readings from Gusev crater. Combined measurements show mineral signatures that form only in liquid water. The pattern indicates more extensive past hydration than single observations suggested. On Venus, new models from ETH Zurich suggest rift valleys remain geologically active rather than ancient relics. The findings will shape instrument priorities for upcoming Venus missions. Turning to our own star, the European Space Agency will stream the 12 August total solar eclipse live from Spain. The agency will stream the event from 1930 to 2045 Central European summertime. Ground activities are scheduled in León, alongside the remote broadcast. Educational materials and graphics accompany the coverage. Observers describe the sudden violet twilight, temperature drop, and unusual animal behavior during totality. The event draws international visitors to the path of the moon's shadow. Multiple commercial lunar landers are now in final cleanroom testing for NASA moon base flights. Each vehicle is being prepared in separate facilities across the United States. The work focuses on propulsion, landing systems, and payload interfaces. The European Space Policy Institute has released findings on orbital data infrastructure. Reliance on non-European data centers in orbit is increasing according to the analysis. U.S. commercial programs and Chinese state efforts are both accelerating space-based computing capacity. The report identifies a widening difference in overall capability. Coordinated European investment is presented as the necessary response to narrow that gap. Coverage of the assessment appears in Space News. A high school team from Hungary won first place at CanSat with their SAS-3 microsatellite. The probe carried a downward 4K camera, FLIR thermal imager, and ESP32 SAS-3 telemetry system. Real-time data included altitude, pressure, temperature, acceleration, and GPS. The project earned a special award for suborbital systems. Astronaut Chris Williams returned on 27 July after 8 months aboard the International Space Station. The live session reviewed experiments conducted during the flight and post-landing medical checks. Data from the mission will contribute to long-duration crew health studies. A Falcon 9 launch from Cape Canaveral carried AST SpaceMobile's Bluebird 11, 12, and 13 spacecraft. Each satellite is designed for direct-to-cell connectivity. Deployment was confirmed shortly after separation. Refined orbital calculations now indicate the Falcon 9 upper stage will strike the Moon on a known trajectory. Impact timing and location will be monitored by orbiting spacecraft. The event offers a chance to study fresh crater formation. The polarimeter to unify the corona and heliosphere mission demonstrated 30-minute solar storm forecasts during a test eruption. Continuous imagery allowed arrival predictions within half an hour. Results are under review at Space Weather. Recent images highlight spokes in Saturn's B ring. The spokes appear and fade over hours, linked to the planet's magnetic field and ring particle interactions. Scientists will answer questions on past, present, and future Mars missions during the 5 August Reddit AMA in the r/AskScience community. Topics include rover findings from multiple surface missions. Sample return planning forms another focus of the discussion. Upcoming orbiter observations are also on the agenda. The session is hosted within the r/AskScience community on the platform. Before we go, keep an eye on the next round of refined impact predictions for that Falcon 9 upper stage as orbiting spacecraft begin their monitoring campaign. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. This show comes to you from the NERA Network. If you want another sharp daily briefing, Offshore North has you covered. Offshore ocean racing explained every Monday, with a Canadian angle. All our shows are free at neranetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at neranetwork.com, the DP Pod. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through